Hi, welcome to the SANS webinar. I'm Cary Wright, VP of Products at Endace, and I'm going to talk today about defending the hybrid cloud with packet capture. Quick summary of where we're at with our cloud transition. You can see cloud is growing rapidly. No secret about that. What's important to note here is that 2025 is the crossover point where our cloud spending exceeds spending on traditional IT services or traditional data center services. So it's important to note that because that's when the attack surface of cloud exceeds the attack surface of traditional IT. So we need to be prepared. We need to be putting in place our incident response process, our defense processes early. We need to make sure they're ready to go. And we're actively defending as we get to this crossover point. In fact, that needs to be happening now. If we think about cloud, especially for infrastructure as a service, really the cloud is just someone else's computer. We're renting it. We're putting our services on it, we're putting our applications on it, we're doing what we need to do with that compute infrastructure, just as we would in the private data center. So we need to defend it as we would. So think about this. If the cloud is just someone else's computer, who's responsible for securing it? So I'd like to spend a few moments talking about this shared responsibility model. The shared responsibility model is really important to understand. It's key for us to understand that the cloud service provider is not going to look after all aspects of security. In fact, when we break this down, most of the responsibility lies on the tenant. That's us. So yes, the cloud service provider is going to be securing the facility. They're going to be looking after the infrastructure, that is the servers, the hosting infrastructure, the hypervisors, the network, the storage, etc. They'll be providing some tools for us to use. So identity access management, VPNs, network routing, etc., ACLs. But we need to use those properly. We need to deploy them that's appropriate in a way that's appropriate for our environment. And we need to put in place all the other security measures that are needed to properly secure the cloud. So you think about it, we need to configure all of the cloud services, the identity services, the networking services, including firewalls, WAFs, NDRs, etc. We need to be looking after the VMs. The operating systems that we deploy need to be up to date. We need to be looking after the containers properly. The applications, we need that software supply chain to be secure. We need to be monitoring those services, providing security to the APIs, making sure the endpoints are not going rogue on us. The data that we collect, the data that we manage, needs to be secured via encryption and securely accessed at rest and in motion. And we need to have all the monitoring capability in place. So network monitoring, endpoint monitoring, taking account of all of our assets, looking at user behaviors, intelligence, threat intelligence, anomalies, etc. And for that, we're going to need to put in place packet capture, logging, SIEMs, dashboards. We'll need to be doing vulnerability management, mitigating 0 days, responding to incidents, remediating attacks. There's a lot for us to do. So it's really balanced heavily on our side of the court. So tenants are responsible for the security at the end of the day. And I would say this, you cannot manage what you cannot see. And logs are not enough. So you think about it, if we're trying to manage everything with logs, logs are vulnerable to attack. They could be deleted, they could be edited, they could be manipulated. When we're defending our network, we need solid evidence. And the network traffic holds those clues. It holds the real evidence. So network visibility, as we discovered with our private data centers, we put in a lot of network visibility and it really paid dividends. It gave us a visibility that we needed to defend against really serious attacks. network visibility is just as important in the cloud as it is on-premise. And packet capture is a key part of that network visibility. So packet capture provides us with irrefutable evidence. It's uncompromising. We can see exactly what happened before, during, and after any event. Think of it as the hard evidence that we can use when we're hunting for really serious threats. It's a complete record of everything that happened. Every file that entered or left our network, every piece of malware, every command and control channel has to travel across the network. So it's a really important piece of evidence. It's a definitive record of everything that happened. So it's important to get that in place. And I want to talk about how we can do that within cloud, because it's a little bit of a mystery to some folks of how to put network visibility into our cloud infrastructure. So let's talk about the solution. And I want to talk specifically about how to do packet capture across our whole environment. So the key is we need to record everything that happens in every location that we operate. So today we record network traffic in our private data centers, in key locations, so that we can see everything coming and going. We've got a complete record and we can quickly go back and analyze. And the idea is that we need to extend that across our cloud as well. So in each cloud environment, we need to put in place network recording so that we can capture the important traffic at the various tiers of our deployment in cloud as well as in physical infrastructure. And that needs to be connected to our global recording fabric so that we can search, and apologies for going backwards there, so we can search centrally from one single console. So from one console, we should be able to look at threats, whether they reside within our cloud or our physical infrastructure, and come up with the packets of interest, the important packets that we need to see very quickly. And that needs to be integrated with the rest of our security and work performance monitoring tool workflow. So for instance, we may have in place SIEMs, IDSs, NDRs, SOAR platforms, etc. When we're using those platforms, we'll be digging into various threats and alerts and issues. What's really helpful is for us to be able to get to the relevant packets from within that tool and do it very quickly. So having workflow integration, having the tools integrated so that they can pull packets from the right environment and display it so you can quickly triage those incidents is really, really helpful and really critical. So how do we get access to the network traffic, I hear you ask? Well, there are three methods I'd like to talk about here. There are three ways of actually tapping the traffic within our cloud environment so that we can record or monitor that traffic in a reliable and consistent way. The first method is to use a third-party tap agent. Now, many of the packet broker vendors already provide this. You can take one of their agents, install them within the VM that you're deploying, and that'll allow you to then tap the east, west, or north-south traffic from that VM and tunnel it out to a particular location, such as a recording tool that sits within the VPC or the virtual network that you're managing. The idea is to keep all of that traffic locally, keep it contained, so that firstly, you don't incur data egress charges, you're storing it locally, and secondly, so that you can keep it secured within your own VPC and virtual network environment. So virtual tapping agent, that's the first method. The second method is to use a native VPC mirroring service. So these are provided by the cloud service providers. Amazon, for instance, provides a service that you can deploy within your VPC. It's called the VPC Traffic Mirror. And that takes all of the traffic that is going in and out of a VM and allows you to tunnel that and steer a copy of that over to a tool of choice. In this case, you can see I'm monitoring traffic from two locations and sending it to a single recording device. So native cloud service traffic mirroring, that's the second method. The third method is to actually use features within some of the virtual networking devices that you may have deployed within your network. So you may have virtual routers, virtual firewalls, a load balancer, proxy, etc. already deployed. Many of these already have a mirror port or a span output that you can utilize to mirror the traffic that's going in and out of your VPC or your device, your virtual device, and send that over to a recording device or a network monitoring device so that you can actually analyze that traffic and see what's going on. So that is also a very useful method. One advantage to this is that quite often these devices have the ability to output decrypted traffic. So if they're a proxy device or a web load balancer, something like that, where it's actually intercepting and decrypting traffic, then you can have a decrypted stream of the traffic sent to the recording or monitoring device. Now, with those three methods, it's also useful to consider that you may want to have multiple tools, or you might want to do pre-processing of the traffic before you send it to the tool. So a virtual packet broker can also be a very useful device in this network monitoring architecture. So here you can see I'm taking several inputs. I may be filtering, deduplicating, or processing those packets in certain ways by the virtual packet broker, and then I can be replicating that traffic out to multiple devices. And here I'm showing sending it to a recording device and a network monitoring tool. That could be an NDR platform or an AI network detection tool. So the idea is the virtual packet broker gives us more flexibility, and it's compatible with all of those three methods that I talked about earlier. So let's talk about our demo. I'll give you a quick overview of what the demo is all about, and then we'll jump into the demo. The demo I have that I'll show you is actually running in two environments. It's a multi-cloud network packet capture demo. It's running in both AWS and Azure. I've got a simulated web workload in each environment, and I have a network packet capture virtual device deployed alongside each in each location. So I've got an EndaceProbe cloud in AWS and an EndaceProbe cloud in Azure. They're both continuously recording the network traffic. So if I need to go back and look at what happened a week ago or so, I can easily roll back the tape and figure out exactly what happened at that point in time for that particular service. You'll see at the top there I've got a connection between the two. That's really representing my single central search console. I can search across this whole multi-cloud environment with a single action and find the threats of interest. And just to show you what that looks like from a cloud console point of view, you can see here is my AWS console, a quick snapshot of what that looks like. I've got the Investigation Manager, which is my central search console, and I've got my cloud instance of EndaceProbe Capture. And then in the Azure console below, you can see there is a virtual machine that's running my other cloud capture instance. So let's jump over to the demo. I'll start a new investigation called Multi-Cloud Packet Capture Investigation, and select a data source from AWS and a data source from Azure. These are my virtual capture appliances in each of those environments. I will add a traffic breakdown tool so that we can see how much traffic is available in AWS versus Azure. So traffic breakdown by data source will give me that view, and you can see roughly 50% of the traffic on each of those cloud environments. We'll also add traffic breakdown by application type so we can see what sort of applications are running in our network. I can actually display filter on some of those protocols so I can see what's actually sitting underneath, hidden by the bulk of traffic by the top protocols. I can also add a IP directionless IP filter. We have a range of different filter types. This is just one of them. And let me do that, run that filter over the last hour of captured packet data on both AWS and Azure. And what you can see now is that AWS is actually the one that is showing up that particular IP address. And we have a little spike of HTTP traffic there that I want to zoom into further. So I've just zoomed the view, and now it's rendering right in on that HTTP traffic. Display filters allow us to see low and slow protocols in our traffic. Conversations view is very useful for seeing details of each conversation running in our traffic, such as bytes transferred upstream and downstream. Launching Wireshark allows us to run a full instance of Wireshark in the cloud on our hosted Endace Investigation Manager, and it doesn't require us to download any of these PCAPs to our desktop. We can also launch file extraction feature. Extract files allows us to analyze the traffic and reconstruct all of the files and flows that occur within that traffic that we've selected. That gives us a zip file which contains all the Zeek logs associated with that traffic. The Zeek logs can be easily read by a human, gives us some interesting information such as the HTTP log or any other log that Zeek has been able to extract. We also get a full copy of every file that Zeek has been able to extract from the packets of interest. Here we've got a bunch of image files which are quite safe, but you may be able to extract important malware or other threats that have been traversing your network so that you can submit them to a sandbox or other analysis tool, or to see what sort of data has been exfiltrated from your network. That concludes our demo. Thanks for watching, and what we'll do now is open it up for questions.